Hello, good morning. So today we have another webinar. Good morning, everyone. Welcome to our webinar on Raspberry Pi in Smart Factory. I'm Idris, your host for today's session. I think this should be the fifth webinar, or maybe fourth. Fifth, I think fifth. Fifth webinar we have done, and that is related to Raspberry Pi and industry. So before we begin, let's quickly review today's agenda. So we'll have opening and speaker introduction, and then understanding Raspberry Pi in industry, introduction to smart factories, and then we open the first Q&A session. So please ask your questions. Please write it in the comment. Any questions related to Raspberry Pi in smart factory. And then we continue Raspberry Pi product in industry, use cases and live demo. And we open for second Q&A session. And then we proceed with introduction to SHRDC and services. Later I will explain more about SHRDC. And then we closing remarks and next step. Okay. So for today's webinar, we are excited to have two distinguished speakers. Our first speaker is technologist Dr. Chua Wen-Shyan. Hopefully I pronounce it correct. Okay, the head of Malaysian Smart Factory 4.0 at the Selangor Human Resource Development Center, or we call it SHRDC. Dr. Chua is a renowned expert in the field of control and automation systems, fault detection and identification, predictive maintenance strategies, and Industry 4.0 applications. He has led high-impact talent development programs to nurture local talent for Industry 4.0. He is certified Smart Industry Readiness Index Theory and Consumer Sustainability Readiness Index Co-Series Assessor, supporting companies in achieving sustainable smart factories. So please welcome Dr. Chua. How are you today?
Hi, Idris. Hi, everyone. I'm good. Very excited to be here, and of course, excited to share with everyone what we do in Smart Factory, and of course, also helping many to demystify, the use of Raspberry Pis in Smart Factory. I think that will be quite interesting topic to discuss.
Okay, all right. Thank you, Doctor. And then we have another speaker. I think this one you guys know.
This one you guys know.
Our second speaker is Mr. Ober Chu Hong, the Chief Product Officer at Cytron Technologies. Ober is a co-founder of Cytron Technologies and has over 15 years of experience in embedded systems design. He has conducted more than 50 hands-on PIC microcontroller and Arduino workshops and overseas products across various categories, including Raspberry Pi, IoT, and industrial. So, Ober, macam mana? How are you?
Okay, good.
Good, huh? I think you need to update PIC already obsolete lah.
No, PIC is still, PIC is
Relevant,
still relevant because Arduino is using 80 mega, and now 80 mega is under PIC.
Microchip.
Microchip,
Okay.
yeah.
All right. So, thank you, our speaker, and then we proceed to the next slide. Okay. We go to the first topic, understanding Raspberry Pi in industry. So, Mr. Ober, could you please start by giving us a brief overview of Raspberry Pi and its potential in industrial settings? Okay.
Yeah, sure. So next, for those that don't know Raspberry Pi, Raspberry Pi has been around since 2012. So here, it started from the mission to enable more student or school or even university to have a computer and to learn about physical computing. That involves that also include computer science, computer engineering, to encourage more student and more intake of engineering, basically. Okay, so that is the initial mission of Raspberry Pi. But then after a few years, the board have become popular than Raspberry Pi anticipated. Then the target market from education, they move to engineering. Robotics, robots start using Raspberry Pi also. Control and monitoring, for example, automation, production, manufacturing start using Raspberry Pi. Why? Because a lot of engineers, they are actually engineer in daytime, but at night they are actually makers. So at night they explore a lot of engineering stuff, including Raspberry Pi, Arduino, things like that. So now a lot of industrial have been using Raspberry Pi for their machine, even to make machine, not only as a upgrade of the machine, for example, IoT, or to upgrade it to become IR 4.0. Okay, but anyway, if you are using the conventional, not conventional, those single board computer ready-made, for example, Pi 4. The next slide, please. For example, Pi 4, 4B. We are using 4B here. Actually, we should replace this with 5, but 4 is still very popular. So the highlight here is if you are using this to for the industry, you might have some problem. The first one is the wiring. If you look at the wiring, it doesn't have the terminal. It have the USB, the Ethernet, the HDMI, micro HDMI, and the USB-C. And the other port is the CSI and DSI. So that is for the display and also camera. And the GPIO is actually the header. So to connect to a lot of equipment is not convenient using this kind of headers. And another one, the GPIO is the one that enable you to connect to external devices. So for example, if you have a devices, PLC, things like that, you need to use RS Wi-Fi or CAN. But that doesn't allow. The GPIO is actually 3.3 volt and is unprotected. It's not isolated, in other words. So higher voltage, reverse polarity, it will burn the I/O, then it might also burn the whole board. Okay. Then it's power supply. This should be powered by USB-C, or you can go through the headers, 5 volt. But it's still 5 volt. Industry is not very common using 5 volt. Most of industry use 24 or 12 volt. Then of course, lack of industrial standard communication port. The RS-232 is not there. The UART is there, but not very common because UART cannot go very long. The distance cannot go very long. The voltage is 3.3 volt only for the UART. Then RS Wi-Fi is not there also. The CAN is not there also. Then poor Wi-Fi performance due to the PCB antenna. So if you look at the, let me see, the left-hand side top, there's a triangle PCB, green color, light green and the dark green. So the triangle is actually the PCB antenna. So most of the controller in industry, they wanted to protect it. They will put inside a case, and normally the case is a metal case. Then the metal case will attenuate the Wi-Fi and signal. The wireless signal doesn't tear Wi-Fi or Bluetooth, it will attenuate. Then you have a bad wireless connection. So that is the poor Wi-Fi performance because of the PCB antenna. Then enclosure and also heat dissipation. It doesn't come with a proper enclosure for a proper, let's say you have a head for the RS Wi-Fi or CAN or whatever interface that you want, but it doesn't come with that, it's just a bare board. Then you might need to customize, in other words. So that's the problem if you use Pi 4 or Pi 5 single board computer. Okay, so next we have a solution. Raspberry Pi have come up with what they call compute module. So the compute module is meant for industry. Why? They take out the power or the core of the Pi 4 or Pi 5. Pi 5 haven't come out. CN5 haven't come out. Okay, but we know that it's coming soon. So in this example is CN4. So they take the core of the Pi 4B and put it in a module form, compute module form. They call it compute module. But with this, you can customize the I/O. You can customize the terminal. You can customize also the V-in. So this is what we did. Okay. So next is the slide of. Okay. So this is compute module 4. So it's very small. I cannot show you now because it's embedded in our product. Okay. Small footprint, good for customization. Another thing, it comes with the option to have the onboard eMMC flash memory. So it's faster, it's more robust compared to micro SD card. If you use what we call the single board computer on the Pi 4B. Okay. It's fully certified radio module, and this one special because not only is fully certified, there is 2 options. The antenna, you can use the onboard PCB antenna. If you look at the right side of the bottom of the CM4, you'll notice there is a light green triangle over there. So that is the PCB antenna. So you have the option to use that, and on top of that, you have the option to use the external antenna, because there is a software switch to switch to the onboard U.FL connector. So you can connect the U.FL coaxial cable and to the external antenna. So you have the option to do that, but you don't have the option on Pi 4B. Same for Pi 5. You don't have the option to connect to external antenna. Then the RAM size, you can have the option 1 GB until 8 GB. So that is similar to Pi 4B. Okay. Then of course the processor is the same as Pi 4B. So it's Broadcom quad-core Cortex A72 64-bit SoC. Okay. Okay, next. So advantage of if you use Raspberry Pi CN4 in industry, support a lot of software and communication protocol, and it's open source, and also some proprietary. So for example, free one, open source, Python, Node-RED. We'll demonstrate Node-RED later on. A lot of automation or a lot of factory is using Node-RED. Then Grafana is for you to have a very nice dashboard. Codices, it enables you to program like a ladder program for PLC. So those that are familiar with PLC can try Codices. You can have the free account, but we noticed that it allows you to run for 2 hours continuously. So after 2 hours, you stop. So that's a free account. Ignition is another software that enables you to write program with drag and drop code, and also a very nice diagram. Ignition. So it also supports Modbus RTU, Modbus TCP, OPC UA, MQTT, RESTful API, and a lot more. Okay. So a lot of interface, of course, as I said, because we can customize using the CN4, it supports a lot of different industrial interface. So one example is the RS-232. So it doesn't come on the Pi 4B, but with CM4, you can customize the carrier board or the controller, the board, to have RS-232. We actually customize a solution for a local company that monitor medical equipment. I think, we didn't put inside here, but I think we can share that one. They use a lot of RS-232. Okay. and a lot more lah. IS Wi-Fi to support Modbus, RTU, Ethernet. You want 2 Ethernet, you want 3 Ethernet, because one can be Modbus TCP, another one can be Internet, right? And analog input, the single board computer Pi 4B doesn't come with analog input, but we can add it if you use CM4. And it can be edge controller, it can be IoT gateway, it can replace PLC also. It can be a small server inside your factory or industrial PC. So a lot. Okay. So last one is what we are talking about lah. It can be customized. Next is what, this.
Next, yeah, this one is for Dr. Chua. So thank you. Yeah, thank you. Over. Dr. Chua. Okay. Now let's delve into the concept of smart factories. So Dr. Chua, can you explain what smart factory and how Raspberry Pi can contribute to its development?
Sure, no problem. Very happy to do so. So hi everyone. My name is Dr. Chua. I represent the organization called SHRDC, the Selangor Human Resource Development Center. So first off, before I go into what is Smart Factory and how Raspberry Pis play a role in it, okay, let me share a little bit about what we do at the Malaysian Smart Factory 4.0. So the Malaysian Smart Factory 4.0, we started off this journey back in 2018. So we are about 6 years old. In fact, September is always my favorite month, whereby we have a lot of celebrations on Smart Factory this month as we celebrate the Malaysian Smart Factory's birthday this month. So and we started off this collaboration with the Swiss Smart Factory in Switzerland, right? And of course, you may ask why Switzerland? And Switzerland is a very innovative country. And here in the Smart Factory, we also practice a lot of innovation for factories to actually co-develop and co-innovate together. So the Malaysian Smart Factory, what we do is that we work with partners like Citron, right, very closely to look at what kind of applications and use cases that industries need to solve, right? And from there, we actually come up with different solutions. Okay, and from those solutions, that's where we actually then translate it into technology transfer programs, whereby we then introduce them to the industry, right? So this is basically in a nutshell what we do. Okay, we have a space here in Shah Alam, where you all can come and see as well. So on the next slide, let's see. Okay, next. So what is a smart factory? Right, smart factory, basically we talk about it as we call the integration of technologies, right? So a smart factory looks at a horizontal integration, vertical integration across your factory, right, internally and across the supply chain, right? So vertical integration talks about integration from your shop floor all the way to your enterprise resource planning systems, and then within the supply chain, that's where your horizontal integration comes in. Okay, and of course, we also have something called the digital continuity, all right, or the diagonal integration. So that actually talks about the digital factory. So in a nutshell, for smart factory, we talk about operational technologies, okay, how hardware and software talk to each other. That's a very important concept, right? Information system technology, whereby data is then sent to databases, okay, and from the database, then now you are actually using it for data analytics, data science, AI, and so on and so forth, right? And of course, the last part of it is we talk about the digital twin, right? So how can technologies be then integrated to create a digital factory and a digital twin of your particular product, right? And your factory as well. So on the next slide, I'm going to share with you, what it takes to actually integrate a smart factory, right? So as what Uber shared just now on how Raspberry Pi is a very open ecosystem, that actually fits in a lot of what a smart factory criteria should be, right? So a smart factory should be modular, right? Technologies in a smart factory should be modular. It should be scalable. It should be flexible enough, and it should be compatible. So if you think about like the Raspberry Pi concept, right? It's an open architecture, right? Everyone can contribute. Everyone can can put in different systems. The Raspberry Pi OS, is actually open for a lot of different kind of developments. Okay, and then you have many multiple software able to load into the Pi, right? That makes it a very modular, scalable, flexible, and compatible hardware to be used in a smart factory. But of course, the Raspberry Pi on its own, right, as a bare unit, definitely needs some additional work involved to make sure that it is actually robust enough to be handled in the factory, right? So that's where we think about how to enclose it, how to actually come up with the right enclosure, how to actually come up with the right couplers, to actually make sure that your system does not burn out, after a long period of running, right? But generally, the architecture itself, right, being modular, scalable, flexible, and compatible, the Raspberry Pi concept fits in very, very well in this. So on the next slide, we talk about how the integration of technologies can work, right? We talk about a brand neutral approach, whereby we have a multi-vendor kind of a concept, right? So in the ecosystem of a smart factory, we have good partners like Cytron, and Cytron also, their hardware can also link to our other partners in the ecosystem, right? Why it can work that way is because of the open communication protocols. How hardware and software actually links to each other, basically, is how they talk to each other is through open protocols. And one of the other key thing that we notice many industries can actually leverage on is we talk about the open collaboration concept, right? So just now, earlier on, Uber shared okay, we have the Node-RED ecosystem, we have Grafana, we have Ignition, we have the we have the Python kind of programming frameworks, we have Codesys, right? All these are actually open collaboration approaches. Basically, we leverage a lot on open source tech, or we call it community-driven technology, to actually drive industrial implementation and innovation, right? And all this technology, because it is community-driven, you have this concept of rapid prototyping. That means, how do you prototype fast enough to actually implement technologies in a factory? So it can be as fast as a company say that, okay, I go through a training program, they go back, they took an iRIF POC kit, they go in the factory, they link it up, and straight away they get data on the dashboard. That's how fast rapid prototyping should be, right? When you talk about smart factory integration, not go into a factory and then after that you take long time to actually implement technology. So we don't want that, because what we want is reducing the overall time to deploy, because we need to see data live as fast as possible. Basically, we want the whole system to go live as fast as we can, right? So on the next slide, we talk about the topology, okay, how it looks like in a smart factory. So this is an example of a topology where we work with multiple companies to actually integrate a smart factory. So if you look at the shop floor level, you have two different methodologies, okay, of how a smart factory can be integrated. And if you notice, you have two different types of brand or PLC hardware as well. So we have an Omron and we have a Mitsubishi, for example, right? So the iRIF comes in, or the Raspberry Pi comes in quite seamlessly here, right? If you have direct connection to your PLC, okay, automatically the iRIF can talk to the PLC, right? Or Raspberry Pi can talk to the PLC using platforms like Node-RED, right? So they can monitor and control the data within the PLC, right? Using Node-RED as a software tool, right? If you don't have access to your PLCs, okay, or if your machines are quite old, right, or at least older than yourself, maybe for some of you, okay, then then think about a concept of digital retrofitting. So the Raspberry Pi offers you GPIOs, right? So for GPIOs, what Cytron's product called iRIF does is that it actually allows us to have digital inputs, RS-485, digital outputs, analog inputs. So from here, what we can do is we can retrofit machines. So they can connect to the I/O of the machine to gather the data that they need, right? So we have companies that have done that seamlessly, right? And this is actually a very, very interesting approach. Now, if you move up the ladder, right? So then we have the modular controller, right? Where you can host Node-RED, Grafana, and your MES system. We use ERP Next or Metabase. Okay, from there, actually we also have tested, right, that a Raspberry Pi can also host Node-RED, Grafana, MQTT, and also the Influx DB all together. We call it the Ming stack, right? So you can actually host everything as one package, and a company can just open up Grafana, or MQTT anywhere in the factory. So that's as straightforward as that, right? So it could also be that kind of database host, depending on the storage capacity, and also a visualization host. But of course, the graphics of the the graphics of visualizing Grafana has to be on a separate PC for optimum performance, right? So then when you move up the enterprise side, right? So there you have the business intelligence, your ERP integration, your big data, your 9 for analytics, Frafer for production planning and scheduling, and of course you also have visual components for digital factory. And also to note that now we are talking about cybersecurity kind of integrations. So setting up OPN Sense as a firewall, Wazoo agents within your smart factory, that also can be done using the Raspberry Pi ecosystem as well, right? Depending on what we are actually looking at as a gateway, depending on what we are actually looking at as an edge-based cybersecurity kind of system, right? So the next slide, please. Yeah. So then, yeah. So we come to the question now.
All right. Thank you, Dr. Chua. I think there are a lot of the bunch of information that we get from the sharing of Smart Factory. So now we open for the first Q&A session. So actually, this one I just put one of the questions, but I think we can try to check the comment here. We got the questions, but from our speaker. So, Dr. Chua, to Dr. Chua, how can the SMEs approach SHRDC to upskill their staff and further upgrade their factory?
Okay, so SMEs actually they can come and talk to us. What is their potential use cases and what they want to visualize in their factory in terms of digital transformation. Then from there, we actually offer them a pathway program whereby they can actually take up a training program, a list of programs whereby they can actually learn the technology, and at the same time, what we offer them is the post-training support, whereby we actually handhold them to implement their first project. So a flow would look like this. So basically, an SME would say that, okay, I will want to collect data from my machine. I want to actually monitor my downtime. I want to monitor my cycle time. I want to monitor quality issues. So they will then go through a range of programs that we have. Okay, and post of it, what we do is that we actually package POC. We call it the POC loan kit. So what we do is that the POC loan kit has all the related IO relays, and also it also has an iRIF there in one of the POC kits, and then we loan it to them, and then they go back and they do a project. So this actually speeds up the development, okay, of them integrating something in their factory. It upgrades their skills of their staff. At the same time, they can convince their top management faster, right? Because a lot of times, when money is involved or financial is involved, it's very difficult to convince. So with this kind of strategy, we notice that once they have implemented something in the factory, the leadership is more excited because they can actually see something moving. Then of course the rest of it will flow in quite seamlessly, right? So when they want to scale up, they will contact any of our partners to buy more equipment and so on and so forth. So this is how we can actually help SMEs to move forward in a more cost-effective approach.
All right, great. Thank you, Doctor. So we have another questions from audience. This one to Ober. What software and applications are included in the default image found in the Satron website for the iRIF?
Okay. So of course we install the Raspberry Pi OS. It's full desktop. I think for now is Debian 11, which is boost up 64-bit, and by default we actually use Node-RED inside there. So of course Node-RED is being installed also, and there's an example code. So if you open up, you power up the iRIF now, the side OLED will display something. So that is using Node-RED to do everything. So if you actually ask you to connect to the iRIF as a hotspot, as an AP access point, You can use your phone, you can use your laptop, use the Wi-Fi, connect to it. Then the SSID is there, the password is there using the OLED lah. So that everything is on the OLED is using node rate, and it's open source. You can go inside there, you can modify the node rate to become whatever you want. So by default, come with node rate beside the Raspberry Pi OS lah. Yeah.
Okay, great. And then another questions to Dr. Chua. Can you share an example of digital twin?
Okay. That one I will share it in the next few slides. Yeah.
Okay.
So I will share with everyone how it will look like. Yeah.
All right. Thank you. Maybe last question from the slide, because this question is come from during the registration. So got participant asked the question: what is the long-term reliability and limitations of Raspberry Pi in terms of real-time pulse control? So maybe not sure, Ober or yeah.
Real-time pulse control. Not really understand this one. Is because control normally is output from the Raspberry Pi lah. You want to control something, or if it's input, it shouldn't be control. I just want to understand real-time pulse. Maybe it's a counter, I'm not sure. Coming from encoder or something like that. You can also do that. But for iRiv, we did low pulse scan. There's a factory approached us they wanted to count, the rotation. Some of the factory floor, they need to rotate something to pass through some of the SKU or component. But the rotation, there is an encoder at the bottom of the rotor or something like that. It's very slow. So it's like 1 second or 2 seconds per pulse. So that one you can put inside the DI of the iRiv, then you can write program to count it. That one no problem. But if you go until few megahertz or few kilohertz, then because it's OS, it might miss some of the pulse. I will recommend using a microcontroller base to count pulse, high frequency pulse. If that is the question.
Yeah. So maybe if you join, you can further clarify the questions lah. Okay.
Yeah.
All right. So we continue to the next session. So what is next? Raspberry Pi product industry. So maybe Ober, you could please discuss some of the specific Raspberry Pi products that are suitable and fit into industrial applications.
Yeah. So this is more to iRiv, I think. Next please. Okay, so this is more to iRiv here. So iRiv is actually our what we call series of product that we design and produce for industry. So iRiv is actually IR. The IV stand for is a Roman numerical for 4, so it's IR4 lah. So this is iRiv Pi control, to be specific. I have one here. Later when we go to the live, I'll show this one. So some of the spec, power input wide range 10 to 30 volts. So normally you can use 12 volt, let's say. Some of the power supply is 12 volt or 24 volt. Okay, then there is a hidden power input also. You can actually use a USB-C to pair it up if you don't want to use the wide range higher voltage power input lah. So one ICE Wi-Fi for you to do a Modbus RTU. Then RS-232 if you have very old equipment that still use RS-232, because ICE Wi-Fi you can connect to a lot of equipment. It's like what we call a DC change. So that's the advantage of ICE Wi-Fi, one of it. And the distance, the communication distance is wired. It can go up to few hundred meter. We do see few hundred meter before in actual use cases. Then RS-232 is 1-to-1 only. So that's some of the different. Then 1 gigabit Ethernet. Another one is 100 megabits Ethernet. So there are two Ethernet port lah. Then 4 digital input isolated up to 50 volt DC, 50 volt. Okay, another 4 digital output isolated also up to 50 volt. Then 4 analog input isolated among the other interface, but share ground with the 4 analog input lah. So inside the iRIF, there is a mini PCIe socket that can support 4G module. If those that wanted to do 4G LTE, cellular communication wireless, there is a mini PCIe. You slot in the module. There is a hole for external antenna also. Then there is a SIM card slot on the iRIF PCB. You can also slot in the SIM card. Or in other use cases, if you want to do a LoRaWAN communication, the mini PCIe also support that. And another N.2 socket for additional storage. For example, NVMe SSD, the size should be 2242, shorter size. We have tested until 2 terabyte. So I don't know what you want to do with 2 terabyte, but that's the maximum size that we have tested. So it can be a data logger or mini server, maybe that you need additional storage. OLED, for example, OLED just now I mentioned, right? So I connect the iRIF to my computer. During boot up, it will show some of the information. So that OLED is good for headless configuration. Metal case, aluminum and alloy heatsink, so it becomes fanless. You don't need to maintain, because we don't want to change the fan, in other words, because something that moves, it will wear off over time. So we don't want that to happen. And you don't need to worry about the heat dissipation also. We have tested, it works until 65 degrees Celsius. We have also seen, so that is during our test, 65 degrees Celsius. We have also seen until 75 degrees Celsius. Dim wheel mount and more. So that is iRIF Pi control. This is some of the photo. We open up the case. So bottom, actually, we have a very thick heatsink to become a fanless cooling mechanism. And the next picture is actually the bottom of the PCB. The bottom of the PCB. So the CM4 sit under the PCB, where if you look at the left picture, there is a heatsink underneath the PCB. So that is where the CM4 resides in. Okay, next it is. So some of the example, although this is not in factory, because factory they are quite secretive. They don't allow picture to go out. This is actually one of our partner, local partner, SI, system integrator. They actually do a lot of solar farm. So one of the example is we have this in our website. You can go to our tutorial, you just search solar. So ADA solution, they retrofit one of the solar farm, connect the iRIF using IS Wi-Fi to 16 inverter. So that solar farm is actually 1 megawatt solar farm, big 1 megawatt big solar farm. They are 16 inverter. So the inverter doesn't, I think it's 8 years old already. So it doesn't come with IoT enabled equipment. So they need to have a gateway to collect all the data from all 16 inverter, then consolidate the data and put into the cloud. Okay, so this example is the one that I say few hundred meter. One IS Wi-Fi connect to 16 inverter through one IS Wi-Fi port only, and it's few hundred meter length, because it's very big, 1 megawatt solar farm. Okay, next this. So this is the dashboard of the ADA solution also, doing for the similar solar farm, not the same solar farm. Next, so all this is on the iRIF, So you don't really need another cloud to do that. You can actually log into iRIF and look at this. Of course, if you want to do the consolidate all the data, then you put to another cloud, also can, no problem. Okay, so this is OEE example, not on the solar farm, but they did it for another factory lah. This next. So here is another iRIF IO controller. So this is, looks similar, but it's different from PyControl. So iRIF, we still remain the iRIF because it's for industry. So this is IO controller. It's powered by the latest MCU, which is RP2350, dual core, two dual core, to be honest, two dual core, because it comes with ARM Cortex M33 dual core. Then there is also a RISC-V dual core RISC-V inside, but you can either choose one only lah. Okay, and we have designed the controller to have one RJ45 Ethernet interface with the controller using the famous W5500 Ethernet controller. Okay, and one USB-C port to program, and if you want to power it up, later my setup is actually using the USB-C to power up also. You can load program or you can power it up. And 11 isolated digital input up to 50 watt, 4 isolated digital output up to 50 watt, and we have 2 12-bit analog input. You can measure either voltage or current. Later I'll demonstrate also. And V-in through the terminal, wide voltage range also. There is also a real-time clock, RTC, status LED for the power, for the IS-Wi-Fi activities, and then for every D-in and D-out LEDs. So it's easy, very easy for you to troubleshoot during development. And programmable button, LED, and also a passive buzzer. This is the fun part. You can program, because this is controller. So we will actually ship, I think in next 2 weeks. Still waiting for some parts. We will actually ship with example code using my CircuitPython. But because it's a controller, you can actually program it using C or C++, MicroPython, CircuitPython, that we are very familiar with CircuitPython, or the famous Arduino IDE. Soon to be released, actually they have just released last week, that support the new microcontroller. Okay. So next, I think we need to move faster. So this is one example. You can use iRIF as a main controller, communicate with the IOC, the iRIF IOC through either Modbus TCP, this example using Modbus TCP, or you can use IS-45 Modbus RTU. Then the IOC can be used as an IO expander. Okay, so one example. So next, Idris. Some of the comparison, iRIF IOC, IO controller versus the Pi controller. So the major part, I think, is one is using CM4, which is very powerful. It's a computer. Another one is what we call a microcontroller. So the operating system is the major, play a major role here. If you are using Pi controller, it comes with CM4. You have the OS. You can actually load Raspberry Pi OS. You can actually change to Ubuntu. One of our customer in Singapore actually changed to Ubuntu. But for iRIF IOC, because it's used MCU microcontroller, it's a bare metal. So you need to write program from another computer for it. But for iRIF Pi control, you write program on it, okay, with it, okay. So that's the major difference. So from there, the RAM size, the flash, so two different kind of platform. But similar, iRIF IOC can be a controller itself, can stand alone. So for simple automation, you guys can go ahead to use IOC. Next, Idris. So this is one of the diagram, the front diagram. Later I will show you. Next, Idris. example of you want to use as DI, dry contact without any additional power inside it, it works. I have a setup here. Later I'll show you. Next, this. Then this is output. If you, oh no, this is actually, output. The flyback diode is optional lah. So output you need additional supply there lah inside your circuit. Okay, dry contact. Yep. Next, this. This is analog input. There's two channels. You can either configure it to become voltage, to measure voltage, or to measure current. So there is a selector at the back of the IOC, a slide switch. Just switch it to either voltage or to current. Okay. Next, this is an example of using ICE Wi-Fi Modbus TCP RTU. Okay. You can also switch. There is a termination resistor enable switch. Okay. Next, this another one I think is the Ethernet. Modbus TCP lah. So there is a Modbus TCP. You can choose it as internet, or you want to communicate with a host through Modbus TCP also can. Okay. Next, this. Let's move on. This is more to the interface that have on the IRIF IOC. LEDs for all the D-in, D-out, user, power, and RS Wi-Fi. Then there is three buttons. One is for reset, another one is for boot, another one is for user. So reset and boot, we actually embed inside. It's not that easy to press it lah. But user, you can use finger to press it. I will show it later. Next is last one is the software supported C++. That is from Raspberry Pi. You can use it, but we don't really like to use that because it's very syntax intensive. You need to memorize a lot of syntax. We are using CircuitPython for example code, but Arduino have released the library for RP, the new RP, and MicroPython also have. Okay. Next is this is some of the so Dr. Chua just now asked me about the size compared to IRIF Pi control. So the left photo actually show the IRIF Pi control and the IRIF IOC controller side by side. So it's actually smaller, more compact and it's in-built mountable. Next is live demo. Let me share my screen here. Like to make it faster. So this is let me share the hardware setup, the actual hardware setup first. So I have this is my hand. Have IRIF Pi control over here. Connect to IOC, IRIF IO controller to RS Wi-Fi. So this is RS Wi-Fi port using Modbus RTU lah. Okay. So this is IRIF IOC. So the example code inside here is actually IO expansion through the Modbus RTU. So this is what we are doing now. So just to show you, just now, the DI, I can directly use a direct switch. You don't need to have another power in between the circuit. So when I press this, this is connected to the D ground and D1, DI1, digital input 1 over here. So when I press it, automatic, LED here will indicate. So this is hardware from hardware. Okay. Then here I have two analog output. So one is configured as current, another one is configured as voltage. So you might not see because it's okay. One is actually voltage over here. The other one is current. This is 6.6. 6.6. Okay, let me do a shadow here. And this is 20. Let me lower down. 20 milli. Okay, so that's my hardware setup. This two is connected to the analog input here. Okay. Let me close up. So this is actually the node rate that Mr. Choi asked us now. The default program. This is not the default program, but the node rate is inside iRIF. So we modify it to demonstrate the iRIF Pi controller, iRIF IOC here controller. So here, when I change the voltage, you notice here, analog 0. When I change the voltage on the analog device, it will change. The current also same. I lower down. Okay. Then the DI just now. When I press, and you can also configure it to enable counter. Yeah. So once you enable, the counter value will increase. But why a lot? Because the debouncing. So this one you need to use the hardware to do some delay, debouncing. Okay. So that's the actual IOC demonstration. Okay.
All right. So we go back to the slide. What? This one what? Oh, the use case. I think the use case.
Yes.
Okay. Maybe I need to call Dr. Chua. Okay. All right.
Yeah. So I think on use cases for factories, you can see that the Raspberry Pi can be used as a gateway, right? And it can be combined with multiple other different hardwares, right? Like in this case, you can combine it. If you're looking at IO-Link technologies, that's more for smart sensor technology, and then after that, after you have integrated the hardware, you can build the dashboards. In the next slide, something like the OEE dashboard that you can see in the next slide. Haven't popped out yet. Okay, yeah. So this is the kind of system that we do train the participants in to actually set up from hardware all the way to developing your own OEE-based system, right? So that you can actually already run something like this as a template in your factory. The next slide will show you how the iRIF can also be linked with vibration sensors, temperature sensors, humidity sensors, more for asset condition monitoring and maintenance. So this is one of the setup, right, that we have in our space, so that you can come and have a look if you want to are interested. You can also because of RS485 compatibility, so you can also control the inverter, read parameters from the inverter. So basically, it's a very comprehensive use case for asset and utilities monitoring. Yeah. The next slide would be so you can also work as a PLC, right? So just now I think Uber mentioned about codices, right? You can also run it on OpenPLC if you are familiar with it. So OpenPLC is actually a software that I come across many years ago. Fully open source software. The runtime is also open source, and you can run it in any of your Arduino, and also in your Raspberry Pi based interfaces, right? Because OpenPLC, you can actually upload things to the Arduino, and we actually did one use case where we uploaded it on the Arduino Opta, right? So that was quite interesting. So you can fully run it as a PLC. So from the PLC side, if you want to actually learn how to program digital twins, right? There's a software platform called Simumatic, right? Whereby you can see on the right-hand side, there's actually a digital twin system of a robot and also of a conveyor-based system. So you can simulate anything, you can program it, and then you can connect your Raspberry Pi-based interfaces, program it using codices or OpenPLC. It should work the same. Yeah. So this is what the kind of use cases that you can see Raspberry Pis being used in the smart factory. Yeah. And yeah, I think that comes with the question.
All right, thank you, Dr. Chua. So now we open for second session, Q&A. We have a questions here. You said iRIF Pi control flash with Ubuntu, then what needs to be done with the IOs to make them usable?
Okay. Just to be clear, the default OS we flash is actually not Ubuntu, it's Raspberry Pi OS. Ubuntu case is actually one of our customer use Ubuntu. It flash the iRIF Pi controller. But actually this is this question is being answered by Kong also lah. Ubuntu already support the Raspberry Pi IO, GPIO lah by default since the Ubuntu 21.04. So now I think the latest one is 22 point something, right? 22 point something. So you can actually directly use the GPIO lah.
All right. So now you can program even you are using Ubuntu. Next questions. Will
Dr.
be
Hudi.
useful, Dr. Hudi. Will be useful if the default I/O expansion software of the IOC can cater for Modbus ID setting without reprogramming.
Understand. But we might need to, I understand what you mean. We might need to have some input lah to change the ID, right? Yeah, maybe the user programmable button can do that lah. Understand.
All right.
Good feedback. Thanks, Dr. Lee. Yeah.
And then the last questions from the slide. So how to ensure Raspberry Pi is still functioning in harsh industrial environment? Maybe they can provide more examples that we already have run.
Because harsh, I think it's more to the temperature. I'm not sure.
Yeah, I think in industrial environments, the harsh environments would be to look at the temperature and condensation spec of the hardware lah. So if it fits the temperature and condensation spec of the hardware, then I think should be fine. Another thing to always consider is hardwares that are able to handle a lot of electrostatic charges.
ESD.
Yeah, so a lot of some factories, they have too many machines, so there's a lot of discharges. So we have seen cases whereby suddenly out of nowhere the I/O are switching without even anything triggering. Yeah, so these are things that happen in industrial environment. But we have seen Raspberry Pi being used in factories that in harsh environments, but they still last quite long. Yeah, so it's more about how you maintain the cooling, the enclosure, and how you actually design the hardware so that it doesn't overheat over time. Yeah, so I think like some factories I've seen, they use Raspberry Pis with the argon casing. Yeah, that actually helps with the cooling capacities. We have seen them use before iRIF came about. There are other Raspberry Pi based PLCs or hardware also being used, and so far it's actually working fine. More than 2 years running, still working fine. So I would expect the same from the iRIF as well. Yeah.
All right. So thank you. Oh, we have another question. I'm already using iRIF Pi control for my industrial customer. There are questions I'm facing from my customer asking me how stable is the product support for Raspberry Pi compared to conventional PLC.
Okay. Maybe Dr. Chua can help on this. Your use cases is more than us lah.
Yeah, so I think in terms of PLCs, so conventional PLCs are not industrial PCs. Conventional PLCs are basically running like a microcontroller based kind of systems. So in terms of robustness, basically it's just a relay based system that is running in the PLC itself. Whereas like the Pi control, we call it as an industrial PC. Yeah, because it can have an OS, right? And you can actually run other applications with it. So in terms of stability, I would say it depends on the PLC software that you're using, right? Whether or not the PLC software that you're using are able to clock in terms of real time, basically as compared to those industrial PLCs that are already readily available. So the software that you use like Codesys and OpenPLC should be able to match that. Yeah, so it can be a comparable hardware compared to the conventional PLCs that you're already using. So the good benefits of it, I would say that you can actually run it as a PLC and IoT device, right? Because the Pi control can also run IoT at the back end. at the background, so you can actually run the PLC code while you're also doing IoT at the same time. So that actually gives it a bit more capability of being an industrial PLC. So some of the example of industrial PLCs that you can see are like Wago. Wago is also an industrial PLC. Technically, they are also using a Ubuntu or Linux-based kind of OS. Backoff is another brand that also use industrial PLCs. And slowly moving forward, you will see more industrial PLCs being used because they are actually more flexible and in the industry. Yeah, but it takes time to convince your customer or bosses on that changes. Yeah.
Okay, thank you. We have another question. For normally industrial like Omron, they say it out very loud that 10 years of support. So customer have no worry on this. But as we under Pi, it keep changing very fast. So any idea on this?
Oh, I think the Pi. Dr. Chua, you go first.
Go ahead on it.
I think Pi actually it came changing very fast. Actually, it's come out with the new Pi, but the old Pi they have commit. For example, CM4 they have commit that CM4 the earliest obsolete or earliest, not necessarily that time they were obsolete or EOL they call it is 2031. So that is 10 years from they launched from the date that they launched the CM4 31, because the CM4 came out 3 years ago so it's similar things they change fast is because they come up with the new model. So you don't necessarily need to change the new model The CM4 can work, then you stick with it
Yeah. I think another thing to note also is that brands like Omron, Mitsubishi, Siemens, they are good brands. They are definitely good brands. Okay, but one thing to think about is the end of life of products, right? So you will see factories using Omron kind of PLCs. They can last for many years. We have seen many factories like that. But when it comes to new model, new hardware, you will notice that the hardware changes, but not just the hardware changes, the software side also change. So your investment will actually be a little bit more compared to investing in things like a Raspberry Pi based PLC or a PC based PLC, right? Whereby nowadays the software side is actually kept standardized, right? Like Codesys is a standardized software across, and then you have the capability of maintaining the same software even if your hardware upgrades or changes, right? So this is something to think about in the long run when you start deploying hardware to your customers. But it takes a little bit of time to convince, I would say, because Omron, Mitsubishi, all these are already readily available in the market, and they are also very competitive. Yeah, so then you have other brands like Delta, you have other brands like now you have a new China brand in the market coming soon like Recon, right? So these are also big competitions that the end customer will need to decide what works best for their systems, I would say.
All right, thank you, Dr. Chua. So I think this one, Kong answered to Dr. Hudi. Okay, it appears as mass storage device, and then you can set maybe the Modbus ID inside that file.
Yeah, understand.
And then another feedback, quite happy with Arif performance so far. Thank you.
Thank you.
So yeah, we continue. We had already exceeded 12. Maybe Dr. Chua, you can continue to introduce the SHRDC and services.
Can do a quick one So so SHRDC we provide a hands-on program to help companies to actually digitize in a practical way. So if you want to start getting data from your machines, you want to start retrofitting machines, pull data from it, do contact us. We have a range of programs that you can take. We just term it as level 1 to level 4 So level 1 you can collect data, level 2 you visualize and store the data in the database, level 3 you develop your own OEE system. So level 4 you develop your own OEE system. So you can actually learn how to do this. And post-training, what we do is that we also provide loan kits for companies, whereby we actually guide you to implement your first pilot project, right? So very, very step-by-step approach, and it's something that we have supported more than 30 over companies to do the same thing, right? We believe that this is a very good methodology to help companies to implement something and to innovate further and scale, right? And of course, we also welcome you to visit the Smart Factory. That's in my next slide, right? Do come by, visit us at SHRDC, right? We have a space where you can see technologies at work. We can show you more things, right? And we can actually show you a hands-on on how the iRIF actually works in a Smart Factory environment here. Yeah, so do contact us and we are more than happy to host you. Yeah.
All right. So thank you for both insightful presentation from you guys. Then we have learned a lot about the potential of Raspberry Pi in smart factories. Before we conclude, so maybe this one we need to share a bit on our updates on the Raspberry Pi in industry program. So the first one is related to the workshop. So Citron have offered two kind of workshop. The first one is the on-site training. So we need at least 3 sets or 3 packs, okay, from your site. And then another one is 1-day training at our HQ. You need to come to our place. We have 3 slots here: 31st October, 28th November, and 26th December. So this is a final 3 slot for this year. Okay, so grab it while still have stock now. And next example of the workshop. This one where over TM?
This one is at the hotel. We did it for one of the agriculture customer. Yeah.
Okay. And then this one is in our HQ, so they can attend the training, the workshop, and then also we bring them to tour our factory, to our productions, and also our office R&D. All right, and then if you want to know more about our program Raspberry Pi in industry, you can schedule a meeting with our industry expert. Okay, and then we have offer for iRIF IO controller. You can grab it, pre-order, because the product is not ready. It takes around 1 or 2 weeks. Around 1 or 2 weeks. Okay.
Yeah,
so please grab it. And last, if you want to receive a copy of slides or any information, you can scan the QR here. And then please fill out the form, and later we'll email you all the resources. So yes, you can scan the QR.
Dr. Chua, all the SHRDC courses are HRDC claimable, right? Just to...
Yeah. All of them are HRDC claimable. Yeah,
that's good.
So I think that's all for today's webinar. Thank you for those joining the webinar, and then thank you again to Dr. Chua and Ober.
Yeah.
So we end the session here. All right.
Okay.
So please wait.
Bye.
I need to have. Okay.